All right. Well, I don't have anybody live in session right now, but I'm going to go ahead and start the notes so I can get this posted to YouTube in a timely fashion. So we have statistics part 2 for my MCS classes. Now, today we're going to be talking a little bit more about probability. So the first set of notes that we did was on mean, median, mode, and range. Today is all about probability and different types of events. So there are two types of events. So there's independent and there's dependent events. So I'm going to say two types of events. And again, they're broken up into two categories. We have independent and dependent. Now, when you think about the words independent and dependent, you should have some idea of the basic meaning of these words. So independent, usually if we're talking about, in the case of like a person, somebody's independent if they don't depend on somebody else. If they don't depend on somebody else. Somebody's dependent if they depend on somebody else. So like your kids can be considered your dependents because they depend on you for food and money and everything else. Independent, maybe it could be somebody that's not living at home. So it could be somebody that doesn't depend on anybody else for anything like food or money or things like that. So in terms of probability, when we're talking about events, we can also have events that are independent or dependent. And it has essentially the same meaning. Independent means that they don't depend on any other outcomes previous to that event. So if, hold on. Okay, so let's pick back up where we were. So again, we have two types of event, independent and dependent. So when we're talking about an independent event, it's going to be any type of event that doesn't depend on another outcome or another event. So independent doesn't depend on any other outcome or event. Good morning. Thank you for joining. Again, so there's two main types of events. So that's the first. The other would be a dependent. Now, dependent means that it's going to depend on another event or outcome. So, depends on another event outcome. So, now, when we're looking at problems, since we're dealing specifically with probability, one of the things that can tip you off to whether or not a event is dependent or independent is if you're dealing with the same type of event happening over and over. If the number of outcomes remains the same, so the number of possible outcomes remains the same in each event, then they're normally independent events. Whereas if the number of outcomes changes due to the previous events happening, then that's going to be a dependent event. So I'm going to make a little note here. If the number of possible outcomes always remains the same. So again, that's one way to think about independent. Now, that's not the only thing that can make an event independent, but again, if you're doing a repetitive event, in order to keep it independent, the number of outcomes of those similar events would have to stay the same. Whereas a dependent event, the outcome would change. So we'll see some examples here in a little while. If the number of possible outcomes changes due to a previous event. So that's the main idea of what we're going to be talking about for the first part of this. Now, this also leads us straight into probability. So when we're talking about probability is the likelihood of an event occurring. Now, there's lots of definitions out there for probability, but again, probability, the main idea, the likelihood or the chance of something happening. So the likelihood, I'm going to say, of an event occurring. Likelihood, it's always a weird word to spell. All one word. Likelihood of an event occurring. Now, something to note there is that it can be expressed a few different ways. Can be expressed as a fraction, ratio, decimal, or percent. And when we're finding a probability, what we're actually doing is taking the number of events wanted over the total number of possible events. Number of total events possible. Yeah, I could replace the number of events here with outcomes. That might make more sense to some people as well. So again, number of events or outcomes. Number of total events possible. In fact, I actually think I like the word outcomes a little bit better. I'm going to change it for the purpose of our notes. I go back and forth on these words every year, but I think I like the word outcomes for this a little bit better. Number of outcomes. Outcomes. So now, how does this apply? So we're going to take a look at some basic examples of things we can do with probability, like flipping a coin. Flip a coin. It's like I just made that one word, flip a coin. Well, we could ask ourselves, probability of heads. So when you flip a coin, the process of flipping a coin, that is an actual event. And there are two different types of outcomes that can occur from that event. So if we're finding probability of a coin flip and we want to know the possibility of getting heads, we'd have the number of times you could get a head by flipping a coin. So number of heads out of the number of sides of the coin, right? Because again, we want the number of total possible outcomes, which there's only 2 sides to a coin, whereas there's usually on a normal coin only 1 head. So this is the number of outcomes that we want to have happen. We want the probability of heads, so there's only 1 head, and the number of possible outcomes, that's again 2, because it could be either heads or tails on a 2-sided coin. So we can write that as a fraction. We could also actually divide that and write it as a decimal, or we could move that decimal place over and write it as a percent. Now, when I write it as a fraction, again, that is another way of saying that we're writing this as a ratio. It's a 1 out of 2 chance. So again, that is a comparison. Now, another basic idea would be picking a card. So pick a card. An example of this would be picking an ace from a standard deck of cards. So probability of picking an ace from a standard deck. Well, in a deck of cards, you'd have to look at the number of possible outcomes that you want, which is picking an ace. So we need to know the number of actual aces, and we'd also need to know the number of cards. So there are 4 aces in a deck, 1 of each suit, and there's a total of 52 cards. So you have 4 possible outcomes that you want of picking an ace out of 52 possible outcomes, because there's 52 cards. Now you can reduce that as well. And you should always reduce your probability. So 4 out of 52 or 1 out of 13. And again, another way to look at this number is we have 1 ace out of 13 cards in a suit. So we could represent that with a decimal, 0.077 or 7.7. Okay, so now the next part of this, we need to talk about what happens if we have more than 1 event happening. How do you look at the probabilities of more than 1 event happening together? So actually, let me scoot that up for a second. That last part up there in case you didn't get it yet. So if more than 1 event occurs, what you're going to want to do is you're going to want to multiply the probabilities together to get the overall probability of the event. So if more than 1 event occurs, multiply the individual probabilities. To get the overall probability. So let's go back to a coin flip. If you were flipping a coin more than once, so what's the probability? Flip a coin twice. What's the probability of getting heads both times? So in the first coin flip, you have a coin. It's two-sided. Only one of those sides is a head. In the second coin flip, you also have the same coin. It's still two-sided, and you have the possibility of getting a head from one of the sides. When we have this probability each time, and the probability is staying the same, these are independent events. The number of possible outcomes is not changing, and in order to find the overall probability of this coin flip where we get heads both times, we would take the two probabilities and we would multiply them together. So 1/2 times 1/2 equals 1/4. You can also demonstrate this through a chart. So for example, if we started off, we have one of two options, either a heads or a tails. So first event occurs and we have one of those two things happen. Second event occurs, and if you got heads the first time, you could get either heads or tails the second time. If you got tails the first time, you could get either heads or tails the second time. So now, there are 4 branches here to this. The only one that actually works, where we got heads both times, is this one branch, heads and heads. So this is a 1 out of 4 chance, which is the same thing that we got here. Now, you wouldn't want to do this if you had something that's occurring many times. If it's just occurring once or twice and you only have 2 things, not too hard to do. But the more different types of outcomes you have and the more separate events that you have, the harder it'd be to draw a diagram. Instead, you'd want to use multiplication. So now, that final value could be written as 1/4, like that. You could have also done it with the decimals. 0.5 times 0.5 equals 0.25. Again, those are equivalent values, the 1/4 and the 0.25. If you had done it as percents, 50% times 50%, you have got 25%, which again is also equivalent to those first 2 answers. So it doesn't matter if you treat it as a fraction, as a decimal, or as a percent. You still follow the same general rules for probability. If you have 2 events happening at the same time, you have to take the probability of each event, multiply them together. All right. So now, the next thing I want to take a look at is examples of 2 dependent events. So let's move this up. I'm going to look at an example of 2 dependent events. So we're going to look at pick 2 cards from a deck without returning. So on here, this would be an example of a dependent event, because when we have 2 cards being picked from a deck instead of just 1, you're going to have more than one thing that is coming out of that same deck. So on the first one, there's 52 cards, but then the second one is only 51 cards. Let me pause this just for a moment. All right, so picking up where we were, 2 cards from a deck without returning. So again, the number of cards is going to change for each one of the events. So let's look at 2 different problems. We have the first one. So we're doing this, but I'm going to ask, what is the probability of getting 2 hearts? So what is the probability of getting 2 hearts. Now, since we're talking about hearts, you gotta have a little bit of card knowledge in order to answer a question like this. You should know that the number of hearts in a deck, or for any suit that is, it doesn't matter which suit you're talking about, there are 13 of each suit. There are 4 suits, so 13 times 4 gives you a total of 52 cards. So number of cards is 52. Now, here we have our first thing is 13 out of 52. We have 13 cards to choose from. So this is the first event happening with 13 outcomes that we would want to happen out of 52 possible outcomes. But now once I pick a card for the second event, my numbers change. So I pick a new card. But when I go to pick the new card, and again, that's always from where I'm starting from before I actually pick the card. So I had 52 when I picked the first card. When I go to pick the second card, I've already pulled 1 card out of the deck. So there's no longer 52 cards. It'll only be 51 cards. And we also are saying that, well, we already picked a heart for the first one. So we're also having 1 less heart. So it's only going to be 12 out of 51 instead of having 13 out of 52. If we had replaced it, it would have made this an independent event, and we would have 13 out of 52 each time. But again, since we didn't replace the card, the number of cards changed. These are now dependent events. And we're going to take those 2 values and multiply them together. So when you multiply these together, you get 156 over 2,652, which again, you could end up reducing this if you want to, or we could just change it to a decimal, which is 0.059, which as a percent would be 5.9%. So a little bit more complicated as you start taking away values, because it's changing the actual outcome of the next event. So when you have dependent, it's a little more tricky. All right, let's do one more like that. So what is the probability of only one of the 2 being a heart? So same idea, but now you gotta think about how many cards are not hearts. So I gotta think about the number of non-heart cards, which is 39. 2 ways to come up with that number. 52 cards in a deck, there's 13 hearts. So if I subtract 13 from 52, that leaves me with 39. Or you could say, well, each suit has 13. There are 3 other suits. So 3 times 13 is 39. So again, there are 13 there and not hearts. So the first event, there is going to be 13 hearts out of 52. That part hasn't changed. We still have the first event. And that's the fact that we're getting a heart. But then the second event, we're going to multiply. There's 1 less card, so there's now only 51 cards. But since we had, the first one was a heart, the second one then is out of the 39 cards remaining. So the second event is 39 out of 51. Again, we're looking for a non-heart now. So we have 507 over 2,652. Now, one question that I normally get when I'm teaching this in classes, well, nothing about that problem said you had to pick the heart first. So couldn't you've done the non-heart first and then the heart, and wouldn't that change your answer? No, it would keep the answer the same, because whether you had the 39 here or here and switched it with the 13, you're still multiplying the same two numbers, 13 and 39. Because if the first event was not getting the heart, it'd be 39 out of 52. And then getting the heart would be 13 out of 51. But again, when you multiply across the top and you multiply across the bottom. So you'd still be multiplying 52 and 51. You'd still be multiplying 13 and 39, no matter what order they appeared in. So we have our fraction. We go ahead and change it to a decimal, 0.191. And as a percent, 19.1%. And those are our answers. So on the notes, and that's it for today. There's going to be another worksheet tomorrow that includes some more of these problems along with some problems from that first section. If you had struggled on the worksheet from yesterday at all, hopefully this cleared up some of the things that were on that worksheet. I wanted you to try some of those first before I had finished the notes on probability. Tomorrow you'll have a worksheet, which is, again, a review over everything. And then on Friday, you'll have a very short assessment that is going to be, I think it's roughly 10 questions. All right, so that's it for today. Have a good one. And again, I'll be posting this on YouTube and Edsby.